So we have considered several patterns, identified several patterns. There are several other patterns which we have not discussed, but which you can find in the literature. When you design an architecture, as we said, you first do the domain, you develop the domain model. Okay, we develop the conceptual architecture, and then we apply the patterns. So we have several patterns, and actually sometimes, so we have to decide on what pattern to select. In general, or very often, more than one pattern is applicable. Sometimes not. So if you have purely interactive system, so you would not go for pipes and filters pattern, but just MVC pattern, right? And if you lots of stream of data which needs to be processed, you would not go for MVC, but for pipes and filters pattern. But sometimes more than one pattern is applicable. So how should you select this pattern? So it's based on the quality concerns that they address. Again, here's actually you should take into account the stakeholder concerns. What are the concerns of the stakeholders? And based on that, the appropriate patterns need to be selected and applied. This is an example of oscilloscopes. Develop a software architecture for this machine. It's also kind of embedded system. We could define the domain model and then define the module view. We could say, okay, consists of oscilloscopes, max, min, x, y, WFM, accumulate, so all the functions. We could have so many classes here, no little structure. Okay, this is not many classes, but in general you could enter with several classes. Like we have in the conceptual architecture, you could have domains, but no pattern applied yet. So we could apply a pattern. We could say, as an example, let's make it a layered architecture. Okay, where we have user interface, layer visualization, digitization, and hardware. But here, in this example, the boundaries might not be realistic because it's difficult to interact between non-adjacent layers. For example, user interface cannot address digitization or visualization to hardware. If that's needed, then it will appear that this pattern is actually not suitable. You could say I'm going to go for a pipes and filters architecture where I have different filters, which are processing units, as we said. You combine some configuration, you define some configuration. This appears as a better solution, but here it's not directly clear how to model the user input. Okay, so you have to reason about this. What do you want to do? What are the limitations of the patterns? So it's not trivial. It's not trivial to select one pattern, but also it gets more complex because you don't have usually one pattern, but multiple patterns in your system. In general, you have one dominant decomposition, which is based on some pattern. Like our system could be, the dominant decomposition could be just a broker pattern. We have a network layer. We have clients, servers. Okay, we have broker in between. There's dominant decomposition, we could say. And at the client and server side, we could have also different decompositions. For client could have, for example, a layers pattern. Server could be a layer pattern, and each layer could have, for example, you could have MVC pattern, pipes and filters pattern. So there are different kinds of combinations. There's usually one dominant pattern for most important quality concern. For example, if you are in distributed heterogeneous system, interoperability is key. Then you typically go for the broker pattern as a dominant. The pattern includes components or subsystems which might themselves be structured using different patterns. As an example, if you have a layers pattern as a dominant decomposition, as we have seen before, one of the layers, for example, could use a pipes and filter pattern, or even multiple patterns could be used in the same layer, or patterns which define the bridge across the layers. Okay? Different possibilities. Well, if you look at this, just a mind exercise, considering these patterns that we have seen, that we have discussed, could you provide examples of composition of the following architectural patterns? Just give me one example, 2 examples. If I say I have a layer and blackboard pattern, what kind of composition would that be? Okay, what's the layering? For example, presentation, business logic is fairly common, and the resource management. That's the dominant decomposition. Where's the blackboard pattern here? Where could we apply blackboard or repository? So where can we apply? Many. Where can we apply? At the presentation logic layer. Where's IDs? We have a pen here. UI presentation or business logic. Okay, and then data. Where's the repository? Like here, right? Just one simple example. Layers pattern. At the layers, the resource layer, we put the repository pattern. Okay. Could we have model view controller in one of these layers? Or related to one of these layers? User interface could include the views, and the models could be in the business layer. You see? Model view controller. Okay? You could distribute, compose in different ways. Pipes and filters. Could we have pipes and filters here? We have seen this before. Could we have pipes and filters in the business logic? Sure. If the business logic is about processing streaming data, you could equally define it here. Could we have as a dominant decomposition a pipes and filter architecture, and where the filter is a layered system? Is that possible? In principle it is, sure, right? You have filters, and one filter could be very complicated, consisting of very different layers. So in theory, many different combinations are possible. But you have to just check which is the key, which are the key quality concerns, and based on that, define the dominant decomposition. And in dominant decomposition, you look at the specific components and check whether you need to apply other patterns or not. If you don't need to apply patterns, don't apply, of course. So you should not go for pattern hacking. But it's just driven entirely by the stakeholder concerns. Okay? Well, the patterns that we have discussed is described in this book. It's a nice book from Frank Bushman, Meunier, Ronert, Sommerlath and Stahl. Pattern on Software Architecture, a System of Patterns. It has 5 volumes. The second and the other volumes are more about specific concerns like concurrency, resource management. The first one, as we have discussed also here, is about more general purpose patterns. Okay? But you have also, for example, concurrency patterns. Okay? If you are designing architecture, you should know these patterns actually. Okay? Questions about this? Okay. Then we continue with evaluating. Evaluating software architecture, which is actually the last process, last step in the architecture design process. Okay. It's a very important one. We will first look at risk in architecture design, architecture evaluation techniques, and scenario-based evaluation. As an example, this a ship, Swedish ship, WASA, built in 1628. It's the largest warship of the time. It was very nice bridge, but it's a Swedish ship, but very nice architecture. But it happened that it sank on its first voyage without even leaving the Stockholm harbor. Okay? It was built as ordered by the king, and even the king had some impact on the design decisions, and the result was later on. So the ship sank, so you had different stakeholders, but in this case maybe a different prioritization of stakeholder. Okay? So it was a wrong design decision. There are several stories about this, about such failures in history, where we have huge systems, but they just collapse for some reason. We are also developing large systems. Sorry. And we try to actually do our best to design the best architecture. The first thing that we did was, that we said was to define a stable architecture, we have to go for a domain-driven approach. We have to understand the problems, the key stakeholders, the key problems. We have to define the right domain, and based on domain, we define the architecture. Domain-driven approach. Plus, we said to restructure the architecture, to integrate quality concerns, we apply the patterns that we know. Okay? So in that case, at each process, we try to do our best to define the best requirements, the stakeholders, all the stakeholders, the concerns, the problems, do the domain analysis, architecture. So we assume the architecture is okay, and we can implement and be sure about its quality. Okay? That's the assumption, maybe. Is that right? Actually, it's not completely true. Several things can still go wrong in the architecture design process. So what can go wrong in this whole process still? And which should also be derived lessons from the project that you are doing now. Okay? You are really following some case. You do the complete problem analysis, domain analysis, architecture views, patterns, evaluation. So what can go wrong? What can go wrong? Nothing goes wrong. What can go wrong? Mehmet Ali. What can go wrong? You do this all. What can go wrong here? Everything is perfect. Overrun the budget. That's a general, right? So you don't do it in time, within time limit. You have to identify stakeholders. What can go wrong in identifying stakeholders? Answers. What can go wrong? Prioritize. You could have identified the right stakeholders, but wrong priority. Or you could have missed some stakeholders. Okay? What can go wrong in problem analysis? You can forget some important problems. And this could maybe because you have the wrong stakeholders, or you forgot to look at the domain problems or quality problems. Okay? What can go wrong further in domain analysis?
Knowledge sources may be incomplete.
Knowledge sources. We said abstraction quality is important of knowledge source. Abstraction quality, it should be relevant to our problems. It should be objective. It should not be outdated. Okay? You could have identified the wrong knowledge sources, or knowledge source with low abstraction quality, which then leads to a less stable system. What about domains? You could have missed some domains, right? You apply patterns. What can be the problem there? Any problem, Mustafa? Evet, okay.
Our choice can be wrong. For example, time performance trade-off. In our pattern will be slow for us.
Right. Perhaps you have applied. One of the key performance issues is performance, but you have applied a broker pattern, which is for heterogeneous systems. It appears that you don't have really heterogeneous system. You could actually just do with client server, but you add additional performance penalty. Okay, so you could, in any case, you could have applied a wrong or inappropriate pattern, which has, so every application of a pattern has some impact on some concerns, on some quality concerns. Okay? As such, so many things still can go wrong. Okay? We try to apply the best possible method, okay, and look at the right patterns, but you could have applied the wrong method. But as we said, you could just avoid that risk by looking at domain-driven, complement with patterns. You could have inexperienced designers. You don't have domain experts, but they don't know the domain. They don't know patterns. Okay, it will have direct, as we said, it will have an impact on the architecture. Somehow missed some requirements or problems. Problems of stakeholders, quality, computer science. Stakeholder requirements might conflict, and you could have, for example, a different prioritization. Could not find the right domains or overlooked some domains, could not find the right knowledge sources, was mentioned, might include the right concepts but be structured in an inappropriate way. You could have defined a very nice domain concept, domain architecture, the conceptual structure, but you mixed up when applying the patterns. Could be a totally wrong pattern. Or you apply the right pattern, could also be in a wrong way. You define layers pattern, but you define the interactions from the lower level to the higher level, correlations, which should not be. Okay? Inappropriate quality priorities. That is, you have selected the wrong stakeholder concerns, etc., several others. So still several things can go wrong. This is about some Escher movies. Escher is a Dutch artist graphic artists who designed such nice buildings. You can find it on the net. What can we see here? It looks very nice, but in reality they are not realizable. Okay? The same could also be with the software architecture. You could have a very nice architecture, looks great, but it's still not realizable because of the structure. So it can still go wrong. So architecture is the earliest artifact. After stakeholders' requirements, it's one of the earliest artifacts, which has really the largest impact. The largest impact on the complete system, the complete project. If you have a wrong architecture, your project will fail. Okay, that's the bottom line. And implementing the architecture requires lots of resources, time, money, manpower. So you should be sure that your architecture is really of high quality, that it's stable, that it meets the stakeholder concerns. And you don't have the option just to change the architecture in due time, later on. Okay? It's like a high-rise ant nest here soon. One of the ants says, stop construction. The architect wants to make one more change. Usually that's very, very hard. While the system is running, if the system has been built, it's very hard to just, hey, let's change the architecture. It doesn't go like that. Okay? They are very resistant in general, in the organization, the companies, to change their architecture. Okay? So you should be sure that your architecture is stable beforehand, not afterwards. So you should analyze the architecture early on. Early. Yeah, you should analyze for system qualities. Does the architecture meet the stakeholder concerns? If you should predict, you can predict some quality given that architecture. You can, the evaluation early on can provide you mechanisms for understanding how the system will evolve also in the end. Very important, you can identify potential risks. You could say this is the architecture, it means these quality concerns, but beware, we have these kind of risks. Okay? So you should record them. You should make this explicit beforehand. If not, if you have just wrong, inappropriate architecture, if you just go for detailed design, implementation, and later on if you want to still change the architecture, you have just damage control. Damage has already been done. It's very hard to change it. Okay? So how to evaluate the architecture? So we have architecture definition through the whole process, stakeholder identification, requirements, problem analysis, domain analysis, domain modeling. We apply patterns. We apply views, architecture views. That's this whole process. How do we evaluate? Based on some quality criteria derived from these stakeholder concerns. So we have on the one hand architecture, on the other hand quality criteria, the concerns. Then what's architecture evaluation? You just check whether the architecture meets these quality concerns. If that's the case, you can say, okay, go ahead. We have a very nice architecture, very stable architecture. Go for detailed design implementation. If not, you have to redefine the architecture before you go to this step. Why? We said this step is costs lots of resources. Okay, time, manpower, etc. So early evaluation we should do. That's here. So what are the evaluation techniques? There are several evaluation techniques in literature. You have analytic models, simulation, or question-based. And in the question-based, scenario-based analysis is a very popular one and practical one, which we will also use. Let's look at what these techniques are. Analytical models what you do is you define mathematical models of your architecture. And you, based on the mathematical models, you evaluate the quality. For example, what kind of models you can use? You can use process algebra, queuing models, probabilistic models, design structure matrix, linear dynamic programming, etc. Okay? Different techniques which can help you to analyze the quality of the architecture in an analytic manner. What are the advantages? It's fast evaluation. You define some formulas, you'd say, okay, this is it. It's quite precise. Preciseness of mathematical descriptions. Disadvantage, architecture is quite complex, but just putting it in some formulas might be simplification. And in general, it's very hard, very complex to model the quality concerns. Okay? It's not easy. You can define simulations. What's a simulation? You define a prototype, a running system, which models the important components and features of your system. Okay, and you just it's not just user interface prototype, but the just executable prototype. Okay, you can and that you simulate. What's the advantage here? You can model fine level of abstractions, plus it provides you runtime behavior. Simulations provide you the dynamics, so you can see what the dynamic behavior will be. Disadvantage can be slow evaluation, because building a prototype, defining a simulation is not easy, takes some time. Plus it might be difficult to provide a full simulation for the complete architecture. Okay? Usually you can just focus on specific parts. A complete, very detailed simulation of the system is of course the system itself, right? You could, in theory, you could say like that. But the simulation is always some abstraction of the system. The third one, so analytical approach, scenario, simulations. The third one is question-based. And in the question-based, you just ask some questions about the architecture. One of the approaches here is the scenario-based, which is very practical and easy way to evaluate your architecture. What you do here is you take your stakeholders and you ask them to define scenarios. What's a scenario here? It's a brief description of an interaction of a stakeholder with the system. Okay? You could have different stakeholders. Yeah, this is your system. They could all define some questions. What if I do this and that and that? Okay? Don't get confused with another definition of scenario, which is used in the context of use case modeling. Here you have also the definition of scenario, which is defined as instance of a use case, which is a runtime interaction of an actor with the system. Like here, this is a use case. You could have normal flow, this is one scenario, or exceptional flow, another scenario. So that's a different definition. In our case, scenario is just architectural scenario, a brief, like here, a brief description of an interaction of a stakeholder with the system. That's it. Okay, not an instance of a use case. So who are the stakeholders? We have discussed this before. Persons who have any interest in the system, like these guys, the persons, end users, managers, etc. And they have some concerns, quality concerns. Correctness, flexibility, security, interoperability, maintainability, etc. Okay, so you should identify these stakeholders, and they have concerns, quality concerns, but the problem is, in general, is that the quality concerns are vague. Okay, this is an example. You could say, for example, is the system modifiable? This question is quite vague. What does it mean? So you should concretize. You could say, what if we change the color of the user interface? Is that possible? Sure, we have just to change that parameter. So for this, it is possible. What about changing the data format? It's also about modifiability. This is not that easy. Could be a question, an answer. Okay? So quality is fake, and you should be, we should make it more precise, more concrete. And that can be actually done by the use of scenarios. Quality depends actually on the context. Scenarios provides you a view of the context. Although we cannot completely model the context, we can still focus on important parts, okay, for some stakeholders, some concerns, and describe desired or anticipated use of the system using some concrete scenarios, so that quality considerations become more clear. You don't really formalize quality concerns like analytical modeling, but you just define stakeholders and let them describe some concrete scenarios related to the quality concerns. In this way, you can consider multiple quality concerns, but also the benefit is also the evaluation is quite easy. You just describe scenarios, and these scenarios are used to evaluate the architecture. Every stakeholder has different concerns, which are the driver of the architecture, as we have said several times. And different stakeholders see quality in different terms. If we take end user, the concern could be usability, understandability, functionality. Customer, concern is efficiency. Developer, concern is reuse, interoperability, portability. Okay. Maintainer, concern is maintainability, tester, testability, etc. You can just list them, and it appears that every stakeholder actually by definition has also different interest in different concerns. Having said that, you have also different types of scenarios. You can classify this in three. Use scenarios, which is the user's intended interaction with the completed running system. For example, a user downloads document from the file server. It's just use scenario. We have a system, and then you say, I want to download something. Okay. Growth scenario or change scenario, or also said evolution scenarios. They define typical anticipated changes to the system. Okay. For example, a relational database is mapped to an object-oriented database. Your current architecture, you have defined, for example, this case, just the example, is repository, is relational database, and then you say, you have defined a scenario. What if I map this to an object-oriented database? What's the impact? Okay. Very concrete scenario, without any simulations or analytic modeling, but just some questions. Scenario. Growth scenario, change scenario. Exploratory scenarios are scenarios which actually you don't expect that they will ever happen. They are just in the extreme conditions. But you still want to consider these. Half of the servers go down during operation. You know that in general that will not be possible. You expect that it's not possible. Maybe one server will go down, but not 20. Okay, if you have 40 in this case. Okay, but you say what if then? What's the impact? So you want to probe the architecture. What's the impact? So scenarios should be, if you describe this, they should be specific. These scenarios are not useful. System fails, or less useful. What is the system? Which components? Why does it fail when? a much better scenario. So we said scenario should be as concrete as possible. A better scenario is this: database is destroyed and data is recovered from backup files. Okay. So you should. So a scenario-based analysis or evaluation, it's called analysis in general. The key here is to derive the right, an appropriate set of scenarios. How do you do that? Typically, you can hold workshops. For example, in organization, you can just define some date. We say, for the Monday, Tuesday, Wednesday, we will define scenarios which will be used to evaluate the architecture. In this workshop or meeting, you should invite the important stakeholders. Okay? They are in the workshop and you let them just define their scenarios. So you could have a brainstorming session with them. In addition, you could look at the domain or existing systems to derive the potential set of scenarios. If you are dealing with the same kind of applications, it makes sense to make these scenarios reusable. Okay? If you are working on command control systems, of course, it makes sense once you have defined these scenarios to make these scenarios reusable for the next command control application, so that you don't need to elicit these again. Okay? So you should try to identify the scenarios, the right scenarios. What happens if you don't have, you miss some important scenarios? This is an example of the Tacoma Narrows Bridge, which collapsed in 1940. It was designed without enough understanding of the aerodynamics loads. One day there was a heavy storm and then this bridge collapsed. So they didn't take into account, when building this bridge, they didn't take into account the heavy wind loading. That's a typical scenario. So this could be maybe an exploratory scenario. Maybe you don't expect it, that there will be an volcano or whatever. But what this unprepared scenario, there's also a small movie here, which you can see how the bridge moves. We don't see how it collapsed. Perhaps you have seen this at Discovery Channel or National Geographic Channel, whatever. But in the end, it collapsed. So that's the lessons learned here. We should have tried to identify the scenarios. So it's not just, oh, let's do scenario, but it could be very important. Okay? So what's the process? In general process, I will explain next Monday a concrete process, scenario-based architecture analysis method. But in general, it's like this. So you have architecture definition, you have stakeholders plus quality criteria. Based on that, you define the scenarios. Then you get the architecture. If it's okay, you go, realize. If not, redefine. So what does it mean, redefine here? What should we change? We might need to change the architecture, but what does it mean to change the architecture? You might need to go even earlier, right? We might need to go back in the process. We said, hey, this architecture definition is not appropriate. It cannot cope with some quality criteria. Obviously or apparently, some domain concepts we have missed. So we should go back to define domain model. To define the right domain model, we might need to go back to define the right problems, or to define the right requirements. Okay? So it might need, if you are lucky, it could be just like, for example, restructuring a pattern or different application, but it might also have a more dramatic impact. But in any case, you should do this before realizing. Otherwise, you are too late. So here you have the chance. The whole project, maybe the whole organization depends on this, on the architecture. Okay? So is there a systematic approach? Actually, I have now discussed some concepts. What's a scenario? What's a scenario types? Use, change, exploratory. They should be made more concrete. Okay? Their impact. But is there some systematic approach which combines all these steps? There is indeed a systematic approach which we will present next time. But for now we will just wrap up. What's the summary here? Short summary. Software architecture represents a gross level structure. The failures, errors in the architecture will lead to highest impact on the whole project. Because earliest architecture, gross level structure, will have impact on the complete project. As such, architecture should be evaluated before implementing to prevent damage restoration. For that, several architecture evaluation approaches can be identified in the literature, like more analytical, simulation-based, or question-based. Among the question-based approaches, scenario-based approaches is a practical and actually effective way to analyze the architecture with respect to different concerns from different stakeholders. Questions? It's clear? Okay, next time we continue with this, with a more concrete approach. Okay, see you then. Thanks.